This is Geometry, lesson 1.1, points, lines, and planes. So for some basic definitions, a point names a location and has no size. It's usually represented by a dot. So if we were to call something a point, it's usually a capital letter that we're going to see it as. So we would see something like a dot and then the capital letter next to it. So that's point P. A line is a straight path that has no thickness and extends forever. And when it extends forever, that means really in both directions. So a line has arrows on both ends, goes forever. We either name it by a single lowercase letter. So if I put a little L here, that would be line L. Or no matter how many points are on it, I only pick two, right? So let's say this one was A, B, and C. I could call it line AB, or line AC, or line AC. I'm only ever going to use two letters no matter how many there are. So let's just call this line AC. And we use the line above it like that. A plane is a flat surface that extends forever, has no thickness, again like a line, but now it's two-dimensional. So a plane is usually drawn like a four-sided figure. It could be any sided figure. It doesn't actually end here. It extends forever in every direction. We either use a script capital letter, like they could put a fancy looking R in the corner. We call that plane R. Or any 3 points on that plane. Let's call them E, F, and G. So this could be called plane EFG. All right. Collinear, if you know the term co, like together, like cooperate, work together, collinear, co-line, that means they are points that are on the same line. And then coplanar is like co together, and plane. We just learned about a plane being a four-sided figure, kind of what it looks like. So coplanar are going to be points that lie in the same plane. So two or more geometric figures intersect when they have one or more points in common. So the intersection of the figures is the set of the points the figures have in common. So if I have two lines intersecting, they intersect at a single point. But if I have two planes intersecting, they would intersect at a line because it's going to be an infinite number of points where they intersect with each other. So things that we can measure, anything that doesn't go forever, we can measure, right? So far, we can measure a segment, but we cannot measure a line, we cannot measure a point, we cannot measure a plane, right? None of them have a specific amount or value you could put to them. So a point has no dimension. We can't measure a line because it extends forever. We cannot measure a plane because it extends forever. All right, so let's look at these diagrams. For example 1, we're going to use this picture to name some of the following. There are going to be a lot of possible answers here. I'm only going to give one. All right, there's going to be many it could be. So for 4 collinear points, I see this line here has 1, 2, 3, 4 points along it. So that would be point H, point N, point K, and point I. Right? I couldn't say M, N, and O because there's no 4th point drawn on that line for me. Right? So that's why I picked those 4. For part B, a line that contains point M. So point M is here. The line drawn is this one here. So I could call it line P because that is the little lowercase name of that line, or I could call it line MO, line MN. So let's go MO. Line MO, and we put the bar, the arrows above it. A line that contains points H and K. Well, if it's containing both of those points, it could be called line HK. Right? We could also call it anything with an N, right? HN or NK. I could call it HI, or I could call it line R. Another name for line Q. So Q is here. So we see this line right here. So anything using the letters J, K, or L. And again, there's 3 of them here, but I only picked 2. So let's call it line JL. And the intersections of lines P and R. So R is the one that's going up and down here. Here's P. So where they meet is at point N. For our next example, we want a line containing point F. So now here we see 2 different lines and there's a plane. So point F is right here. So we want any line containing that, which I see goes here. So I could again either name it line DF or EF or DE, or I could call it line J. And this time I'll do that, line J. Another name for line K. So K is listed down here, so it's the up and down line. They show this as dashes because it's kind of hiding underneath the plane. We're imagining this line is going through it, and this is the part we wouldn't be able to see if this plane was solid. So any points on that line, C, E, or B, we can use. So let's call it line B. Right, a plane containing point A. So this plane here contains point A. So I could either call it by 3 letters that are not on the same line. So I couldn't pick D, E, and F because they're all on the same line, but I could pick D, E, and A. Or I could call it by its capital letter. So we could say plane M. All right, an example of 3 non-collinear points. So 3 points that don't make one single line together. So again, I wouldn't pick D, E, and F because those are all collinear, but I could pick 2 of them and another point that's not on it, either A, B, or C. Let's say we pick A, C, and F, right? A, C, and F. And then the intersection of line K and plane M. So an intersection of this plane and this line, I see that it hits the plane and starts going through it right here. So that's at point E. All right, one more example together. So here I'm looking for the intersection of lines L and M. So this time I have 2 planes. L is the one that goes through here, M looks like here, so they intersect at point E. Another name for plane Q, so Q is the one listed here, so that's this shape. So I'm going to pick 3 letters not in a line, so we'll pick I, F, and G. So plane I, F, G. Question C I actually have a little bit of an issue with. It's asking are points D and E collinear or coplanar? So if we were just given those 2 choices, D and E, I do see a line forms between them. So I would say collinear. But there is a postulate or a theorem in geometry says through any 2 points, there's a line, and any line can be contained within a plane. So technically, even though it's not drawn, D and E can be considered coplanar. But for the purposes of this question, given the 2 choices, we would say they are collinear. And then how many times do planes P and Q intersect? So if this surface extended forever and this surface extended forever, they're never going to meet. It's like having the front wall and the back wall of something. Those 2 things will never meet each other. So this is actually never or none. So you can try these 2 check-ins, all right? You should be pausing the video here to try them, so that way when you come back, you can hit play and see the answers. All right, so let's check our answers. Another name for line PQ could be line N. That's not the only option, but that's another name for line PQ. Another name for plane R could be plane VST. Again, not the only choice. 3 points that are collinear would be S, P, and T. I believe that's our only answer option for that one. And then for points that are coplanar, this is also our only answer option, S, P, T, and V. We're not using R as a point because if you notice, R doesn't have a dot next to it. R is actually the name of the plane, right? They called it plane R before. For second 2, there are 9 lines in this figure, or points, sorry. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Anything with the dot next to it was a point. How many lines appear? There are 3 lines. How many planes appear? There are 2. Now here we can have some different answers again. 3 collinear points would be M, N, and O. For non-coplanar points, so I picked P, T, which are on the same plane, and then M and U, which are on the same plane, but different planes from each other. For part F, give another name for line E. I chose line MO, could have anything with an N in it also. For G, name the intersection of line PQ and line MO, that was point N. And the intersection of plane K and line C was point S. All right, as we continue with our notes, all right, we have some more definitions. A segment or a line segment is the part of the line consisting of 2 points and all points between them. So we're naming it by the 2 end points, and they're called end points because they're the ends of that segment. So when I'm looking at it, a segment is part of a line, so there could have been arrows here, but when we're only talking about the part between those, that's the segment. So if I had an A and a B here, that would be segment AB, and we put the bar above it without the arrows. All right, so an endpoint is a point at one of the ends of the segment. So A, right, let's put some little arrows here. A is an endpoint and B is an endpoint. A ray is a part of a line that starts at an endpoint, but then extends forever in one direction. So if I had something like this, and I had another point on here, I could call this ray DE. Even if there was another point on that line, say F, I don't have to call it DF, I can. I could call it DE. The only thing I can't do is call it something like ED or EF because D is the endpoint, which is really its starting point, and F and E both go in the direction of the arrow, so either one is allowed to name it, right? And we only put the arrow on one end for a ray. So then opposite rays really make a line. It's 2, like if I start here and go in this direction, but start at the same point and go in the other direction, that makes 1 line. All right, so let's call this J, K, and L. So ray JK and ray JL would be opposite rays. They have the same starting point, but then go in opposite directions. All right, so here, if I wanted to give another name for segment GH, since we have to name a segment by the endpoints, I can't use the J because that's not one of the ends, only G and H are. So the only other way we could name a segment is by flipping it. I could call it HG. But that's the only thing we could really do to modify that. So name all rays with endpoint J, and which of these rays are opposite rays? So let's just focus on naming the opposite rays. So J is the starting point, so I can go towards E. And then if I set J and went in the other direction, I'd go to F. So JE and JF are opposite rays. If I started at J and went to H, then going the opposite way of H would be to G, so that'd be JG. All right, in the check-in, you're going to try it. Again, I would recommend pausing so that you don't see the answers right away. Give it a try, and then unpause to check your answers. All right, so another name for segment KL would be segment LK. Asking, are ray KP and ray PK the same ray, and explain? No, because one starts at K and goes towards P. The other one starts at P and goes towards K. So they start with different points, so they're not the same. And then part C, are ray NP and ray NM the same ray? Yes, because if I start at N and go towards P, that's that ray. And if I start at N and go towards M, it's drawn the same ray. So that is yes. One last thing. We have a diagram that shows a juice box. We want to name two different planes that contain line PQ. So if I notice here, P and Q are these 2 points on the bottom. So this line here is line PQ. So really the front of the box would be one of the planes. So I could name it with 3 of any of those 4 points, like PQN. But also the bottom of the box has that line as a side. So I could use any 3 letters on the bottom, like Q, P, and S. And just to note, the letters can go in any order. You don't have to have a PQN. It could have been NQP or NPQ or QNP. It does not matter. All right, so that's it for the lesson. There is a challenge here if you'd like to try it. So again, if you're going to try those problems, you can pause and then you can check your answers. Otherwise, this is the end of 1.1. All right, so if you tried the challenge problems, we have our 3 sketches. So A was sketch plane M and a line B that is in the plane. So we have plane M, and then inside that box, I drew line B. For the second one, sketch line ST that does not intersect plane R. So I drew my plane R and I drew a line so that it was not intersecting with that plane. And then for part C, sketch line D that intersects plane K in only 1 point. So if this is plane K, our line passes through it at point A, and that's called line D. And now if you did try these, this is really the end of section 1.1.